All right, so now, for example, 4, we're supposed to be looking for asymptotes and a whole. So they've given us this equation and they're asking us to graph it, and we're not going to use our graphing calculator. So the first thing that works for me actually is the y asymptote. It's just easier to figure out than the x one right off the bat because there's just a few simple rules, right? So for this one, I've got x over x squared. And I know that if my numerator has a smaller degree than my denominator like this, then I'm going to have an asymptote at y equals 0. So that's an easy thing to put in right away. I can just say that this is actually my asymptote. And yay, I've got an asymptote. Now I can carry on. It's not going to have an oblique asymptote because I don't have x squared over x, so the degree on the top is not bigger, so that's fine. I don't have to worry about any of that stuff, but I do have this big gigantic mess on the bottom which looks like it's going to need to be factored in order for me to find out what my vertical asymptotes are. So again, this is got a 2 here, so I'm going to have to use decomposition to figure it out. So I've got, we'll just start there, 2 times 9 gives me 18, and I need to know the factors of 18 that are going to add to 9. Now this is a positive and a positive, so all of my numbers are going to be positive, so I'm actually looking for something that adds up to that. So 1 and 18, 2 and 9, 3 and 6, oh, there we go, 3 and 6 add to 9. So I can write out my 2x squared plus 6x plus 3x plus 9, and then I can factor out the first 2 terms, so I have my 2x times x plus 3. My second 2 terms, there's a positive sign here with a 3, which gives me x plus 3 in the brackets as well. So now I just group them, 2x plus 3 times x plus 3. This is all my, well, it doesn't really matter. These ones are the ones that are going to have to equal 0 for my asymptotes. So for this asymptote, I've got x equals negative 3. And for this asymptote, I've got x equals negative 3 over 2. And if you're wondering how I do that, you can either write it out, 2x plus 3 equals 0, and then solve it algebraically, or you can just recognize that you switch the symbol and you put this number under there. It's just a really quick way to do it. Anyhow, we've got our asymptotes now. But what we see is that we've got a whole, actually, because I've got 2x plus 3 on the top and the bottom. So I can rewrite that, if it helps, that I've written it out now as 2x plus 3 over 2x plus 3 times x plus 3. So I've got, these are my factors, and I've just put them in there that way, which shows me that these guys are going to be canceled out, and the x value that goes with them is a whole. So in order to find out where that whole is, I'm going to have to modify this equation, and I'm going to write out what's left. So everything on the top has been canceled out, so I leave a 1 there, and I just leave what's under the way it is, and then I have to actually put that value into this equation and solve it. So I'm going to end up with y equals 1 over negative 3 over 2 plus 3, and I know some of you guys are going, why don't you just make it into a decimal? Fine, I'll make it into a decimal just for you. So negative 1.5 plus 3, which gives me 1 over 1.5. That sucks. I could just blow it up and make it 2 over 3. Oh, look, it's 2/3, which is 0.6 forever for those of you who like decimals better than fractions. All right, so I'm just trying to figure out where to write this. My whole is going to be at negative 1.5 and 0.6 forever. I can mark that on my graph. I can go -1, there's -2, and there's 1, so my whole is going to be at 1.5 and 0.6 forever. So there's the whole. It's just kind of floating there for now, but we'll stabilize it later. Now, the x equals -3 is a true asymptote, so I can write that in here where my x is -3 and make my vertical asymptote where it's supposed to be. And again, we can cheat a little bit because we have that hole sitting there, so we know that we're just going to have to do that and that in order to finish the sketch there. And there's a good chance that the rest of the graph is going to be over here. We should probably do a little check to make sure, so we'll just do our little table, x and y. And since this is at, where did we put it? -3, should have written that in. Then I'm just going to test it on this side. So I'm just going to make a quick value here of -3.01. And when I throw that into this equation, just using your calculator, you can use your calculator for that, you're going to get -100, which means that this value is going to be coming up from the negatives, can't touch that, so it's going to keep going like that. Makes sense. The asymptotes are doing opposite things on either side, which is pretty normal, and so that's pretty much her. Domain and range. Almost forgot, didn't. So when we look at this graph, our domain, the values that x can be, have 2 limitations, not just one. They cannot be -3/2, and they cannot be -3. For range, though, I have an actual limitation on range this time because I have a horizontal asymptote, so y cannot be 0. There's another value that y cannot be, right there. So you can write it like this, or you can write it just as they're together, but it also can't be 2/3, or 0.6, whatever you want to call it. So we've got 2 limitations on domain, 2 limitations on range, and you just list them and you're good to go.